Hey, Cole. How are you today?
Hey, doing good. How are you?
Good. So what are we going to work on today?
I don't really have anything that I'm struggling with. I think I have a good grasp on it. So if we could, I'd like to work on some SAT practice.
Okay. I made a note that we had made it through number 11. So let's pick up from there. And I have digitized more SAT tests. So I have a total of 4 in my computer now, and I've got 4 more that I can put in there. So we'll have plenty of SAT stuff to go over. Let's see, that's number 1. Yeah, 11. If you'll remember, you set one equation equal to the other, and that tells you where B is equal to C.
Mm-hmm.
All right, number 12. Hold on. Let me move it a little bit that way so that I can bring up my other page also. Can you read that okay?
Yeah.
Tell me what the equation of that line is.
Y equals 1/7 x.
Okay. Now it's easy to figure out which of those points lie on that line. It's point A.
No, it can't be point A because
Point B.
it goes to the origin. No, it can't be point B.
Point C.
No, it'd be point D because
Good.
14 divided by 2 is 2.
14 divided
14
by
divided by 5 is 7 is 2. Sorry.
2. That's okay. Hold on. Let me see if I can just blow this up a little bit. And that should help a little. 13.
Um, I don't understand.
Okay. Well, what we have to do is algebraically manipulate this expression. How do I add those two fractions?
Need to have a common denominator of x plus 2 times x plus 3.
And here, let me expand this a little bit. Excuse me. This is the new denominator. Hold on, let me rewrite this again. Make sure you understand we're only talking about the denominator here.
Yeah.
What goes here?
1?
No? In other words, whatever goes there has to make this thing the same as that.
Okay.
Well, what would I have to put there to make it the same as that? Remember how you do these. Once you come up with a least common denominator, which we have here.
You multiply top and bottom. Yeah, so it would be x plus 3.
And over here.
X plus 2.
All right. Now, that's what we have. Right?
Mm-hmm.
Okay. Now let's simplify the bottom. What does the bottom become?
X plus 3 times x plus 2 over x plus 3 times x plus 2.
Well, simplify that.
1.
No, what's x plus 3 plus x plus 2?
Oh, 2x plus 5.
Yeah, so the bottom becomes this. Right?
Mm-hmm.
Now, that whole thing's being divided by 1. How do we do that? In other words, we have 1 being divided by a fraction.
Multiply.
What's 1 divided by 3/4 equal to? You flip the bottom and multiply instead of divide.
Okay.
And that's, whenever you're dividing by a fraction, always remember that you're never going to divide it. You're going to flip it and multiply. So this over here is equal to 4/3. Well, do the same thing in this problem. Flip and multiply. What do you get? Remember, this is the denominator.
So you'd get... I'm sorry, I'm not understanding this whatsoever. I've literally never seen anything like this before.
Well, it's a little bit of a hard problem. Okay, first of all, we started with this. Okay? We cannot flip and multiply because we've got 2 terms in the denominator. So the very first thing we have to do is combine those 2 fractions in the denominator. And we did that here. And then when we simplify that, we get 2x plus 5 over that common denominator. 1 divided by all of that. So if I flip the denominator and multiply, I get this. See how?
Yeah.
All right, let's look and see if that answer is part of the multiple choice. Well, it is. It's just disguised a little bit. Which is the correct answer? A,
B.
C, or D?
B.
Yeah. In other words, they went ahead and multiplied these 2 factors together to get x squared plus 5x plus 6. But it doesn't matter as long as you recognize. In other words, this could have just as easily been an answer as what they gave.
Mm-hmm.
You don't always have to multiply stuff together. In fact, I've kind of found that you're better off not multiplying 2 factors together unless you have to. And when we look at our multiple choices here, we have to do it. So we do it. But you don't always do it. Okay?
Mm-hmm.
So I'm a little concerned about your confusion here. Let's go back. This is the original problem.
I understand it now, but I've literally never seen a problem like this.
Okay. All right. As long as you understand it now. In other words, here's the thing. If I have 1 over A plus 1 over B, I cannot do that by flipping and multiplying. Not yet, because I have two terms in the denominator. In other words, if I said, what is 1 over 1/3 plus 1/4? Well, I cannot flip that. That is not the same as 3 plus 4 times 1. You with me?
Mm-hmm.
So what I would have to do here is add the two fractions. So what I really have is 1 over 4/12 plus 3/12, which is 1 over 7/12. Now I flip and multiply and I get 12/7. So that's what that is 12/7.
Okay.
And our problem was really no different than that. It was just a little more complicated. Instead of 1 over a, it was 1 over x plus 2. And instead of 1 over b, it was 1 over x plus 3. But still, the only way to begin this problem is to combine those two terms.
Mm-hmm.
Once you do that, then you have a single denominator. Then you can flip and multiply. By a single denominator, I mean a rational quotient. I mean a over b or x over y. But it can't be 1 over x plus 1 over y.
Yeah.
That's the most important thing for you to take from this problem, is that in order to do a division problem involving fractions, you have to have the denominator be a single rational quotient. It cannot be two rational quotients added together, which is what we had there. All right, let's see. Well, I guess we got to go down for 14. All right. We have 3x minus y equals 12, and they want to know what 8 to the x over 2 to the y is.
So you just need to solve for both variables with the given equation.
Solve for one variable only.
One variable only?
What's the easiest variable to solve for?
Y?
Okay, what's y equal to?
Negative 12?
When you're solving for y, move the y to the right and everything else to the left. That's what y is.
Okay. Well,
as opposed to the other way around. In other words, whenever you're solving an equation, you want to figure out which side to put your primary variable on. And you should determine that by whether you're going to end up with a positive or a negative coefficient. Well, I see that it's easiest to solve for y, but it's got a negative in front of it, so I'm going to move it to the right, turning it positive, and then if I move the 12 to the left, I'll have the expression. Okay? Now I can attempt to solve this by, I have the same variables. It's no longer 2 to the y, it's 2 to the 3x minus 12. Now, how do we solve that?
you'd have to subtract the exponent. No, you don't.
Only if the bases are the same can you do
Which they're not. So.
Right, but they do share a common exponential base. What is it?
2.
So how can I write 8?
4 times 2 to the x power.
No, that won't work. Got to write it as 2 cubed. Now simplify the numerator. What's 2 cubed to the x power? Remember your rules of exponents.
To the x over 3 power.
You multiply exponents. Whenever you are doing double exponentiation, and that's what I call this in the numerator, in other words, I'm exponentiating 2, but I'm also exponentiating the whole expression to something else. Well, that's, you multiply the exponents. Okay? Now I have same base, different exponents. How do I do that? In other words, I'm doing division, and I have same base. As long as you have same base, everything's pretty easy. What do you do with the exponents? You add them, you subtract them. So what's 3x minus the quantity, 3x minus 12?
Minus 12, negative 12.
Look at it again. That negative sign needs to be distributed to both terms.
So positive 12?
Uh-huh. So this answer is 2 to the positive 12. And that's going to be one of our multiple choices, I'm pretty sure. Yeah, it's A. Now, let's back up just a second. The secret to all of these problems is always to find a common, not factor, but exponential base. Notice that had, instead of writing it 2 to the third, I would have written it 4 times 2, which is correct, but it doesn't get me anywhere. In other words, I'm dividing by 2 to some exponent. So I've got to get the entire numerator in terms of 2 to some exponent. So you don't find factors, you find common exponential bases. For example, 27 to the 3x plus 1 divided by 9 to the x. How am I going to do this problem?
Write it as 3 cubed. Top is 3 cubed. Quantity 3x plus 1. Multiply it. You get 9x plus 3.
Hold on.
Over 9x.
Let's do it one step at a time. What's the bottom become?
9x. 9 to the x power, sorry.
No, it's only going to work is if I get the same base. So it's not 9, it's 3 squared. Like that. In other words, I can only solve this problem if I can turn 27 and 9 into the same exponential base. Not factor, but exponential base. And that exponential base is 3. 9 is 3 squared, 27 is 3 cubed. Now I can apply the rules of exponents. What's the numerator?
3 to the 9x plus 3.
What's the denominator?
3 to the 2x.
Now I can subtract. Because I have the same exponential base, or because I have the same base, I can divide by subtracting exponents. So my answer would be 3 to the 7x plus 3.
Okay.
Okay. So whenever you're looking, and they always give you these small numbers. You may see a 64. 64 is 4 cubed. But never make the mistake of looking for common factors. It's not common factors we're looking for. It's common exponential bases. What's the common exponential base between that and this?
X. Oh, it's, sorry,
What if I was multiplying them?
2.
Yes, exactly. It's 2. It's not 4. Okay? In other words, if I'm multiplying those two, I only really have, other than using logs, and I should tell you that there's not a lot of logs on the SAT. Okay? You don't have to worry about knowing logs. But the closest thing they give you to log questions are these where there's a common exponential base. Well, it's not 4. I cannot express 8 as 4 raised to anything. So it's 2. I can write 8 as 2 cubed to the x power times 2 squared to the 2x power. And now that becomes 2 to the 3x times 2 to the 4x, which gives you 2 to the 7x. So this is a key question. You're definitely going to see problems regarding common exponential bases on this test. And this takes it kind of a step further in that they give you two different variables, x and y. So you have to convert one of these variables into the other one. And they give you this other equation that lets you do it. So in a way, what we really have here is a system of simultaneous equations. This is one of them. This is the other. Well, this is one of them, and they're asking you what this is. And the only way to figure out this one is to convert one of these variables so that it's a function of the other variable.
Mm-hmm.
Number 15. These are definitely not easy questions. And that I'm glad. In other words, this is really the ultimate practice test. Hold on. Only I could figure out Windows, I'd be in good shape. All right. That's a good question too. All of these questions are difficult. Just because it's 15 doesn't mean it's not difficult. When you see something like this, what's your first step have to be?
Foil out the...
Yes, do it.
So it'd be ax bx.
Hold on. AB x squared.
X squared. Okay.
Keep going.
Plus 7ax
Plus,
2bx plus 14.
okay. That's the left side. Right side didn't change. Now, what can I say about that and that? If the left side is equal to the right side, first of all, let's get rid of the 14. That can cancel immediately. This is called equating coefficients. I only have one term on the right side of this equation that's an x squared. I only have one term on the left side that's an x squared.
Okay, so it has to be 15.
AB has to equal 15. Now, let's figure out that and that. Factor out an x.
If it's 15 and you know that a plus b equals 8, 3 plus 5 is 8, and 3 by 5 is 15.
Okay, cool. You got ahead of me, but that's fine. I'm glad to see it.
Okay.
So 3 by 5?
Yeah, 3 by 5.
Possible answers? Yeah.
Mm-hmm.
Okay, cool. I was getting there.
No, you're good. I just saw that and I was just like, oh, that's
Yeah, no, that's fine. I love it when that happens. I love it when I don't have to fully explain the problem, but the student realizes what the answer is immediately. All right, we got time for one of these, maybe.
all right.
These are grid problems. Never had to face these on the ACT, but the SAT has always had grid problems, non-multiple choice. And in fact, this is not only non-multiple choice, it's non-calculator. That X through the calculator there means no calculator allowed. So let's do this one. T squared minus 4 equals 0. T is greater than 0. What's the answer? What's the value of T?
2.
Yeah, but just before we go on, I want to be crystal clear. No, you were correct.
Okay.
T squared is equal to 4, and whenever you solve an equation by taking the square root, you should begin your answer with plus or minus.
But if it says greater than 0, it has to be positive.
If only greater than 0, then that eliminates the minus answer.
Okay.
Okay? But never forget that it's always plus or minus 2 until further information is given. All right, let's stop there, and I'll make a note that we got through 16. And, well, this is fine. Doing SAT is going to be really valuable to you. Just please don't make the mistake that one of my students made with me.
Yeah. I'll make sure that if there's anything in class that I'm having trouble with, I'll make sure.
I just got to tell you this story because it's kind of funny. I started working with this student in the summer on ACT. He was consistently scoring 31 to 32, which is like 97th percentile. He was getting ready to take trig the next semester at the end of the summer. And so at the end of the summer, he started trig. And every time we had a session, he said, yeah, I want to work on ACT. I'm doing fine on trig. I'm doing fine on trig. I'm doing fine on trig every single session. And he just got better and better at ACT. And at the end of the semester, I get an email from his mother saying, you're fired. He just flunked trig. Not kidding. True story.
Jeez. That's crazy.
He had been embarrassed to tell me that he was not doing well in trig. And so he constantly went to something that he felt really good about, which was his ability to do ACT. And he never, ever gave me any indication for an entire semester that he was having trouble with trig. True story. So don't let that happen. Not that I think you would. First of all, you're doing fine in Algebra 2 from everything that you've shown me so far. But do not let yourself get behind in Algebra 2.
Yeah.
All right? Okay, Cole. I'll talk to you.
Awesome.
Bye-bye.
All right. Bye-bye.